Welcome back to another episode of Version Control. I'm Soumya. I'm a senior software engineer at Microsoft, and with me,
I'm Sarthak. I'm a software engineer at Amazon.
it is so hard to talk to you normally because, off camera we just had like one of the biggest sibling fights ever.
Yeah, I know, right? And like, it's just so hard to convince you that I'm right always, but you don't listen only.
You want to fight on camera now?
Alright, no, please, let's not do that.
But either way, today we're doing good developer habits. We made a video about like developer habits that annoy us. We did like 2 parts actually, and we had a lot to say. But now we're doing like developer habits that are good, that can help you be a good software engineer, right? So do you want to get us started?
Yeah, I mean, we'll get to that, but
Yeah.
I think this is necessary because one thing I felt doing annoying developer habits was we were complaining a lot, but we never really, I mean, we did give counter advice, but we never really, explored the positive side of it, that there are
Yeah.
good habits that you should keep.
Yeah.
So I think this video is definitely needed for
Yep.
that.
Yeah.
So I'll get it started. I have a list here that I brought with me.
Yeah.
Most of these are from personal experiences.
Right.
Okay, and I think you have a similar list.
Mhm.
So I'll get it started. So the first one I kind of want to mention, and I think this is very, very important if you want to get ahead in career, is that you should raise reasonable size CRs. Right. So what I mean by that is that I have seen developers raise like multi-page CRs, which
Right.
could have been easily broken down into smaller chunks.
Right.
There are advantages to that. You can roll it out safer. You can roll back it safer. You make it digestible for the reviewer. You make it digestible for yourself. Shipping smaller pieces of code is always easier, right? Because you can just focus on that, write
Yeah.
tests for that, and ship it. After that, you work on it as if it is production code,
Right.
right? So I definitely feel that is one of the key lessons to transfer into from a starting engineer to a like at least a mid-level engineer or a
Right.
senior engineer. What do you think?
I think that I totally agree, right? And I think as a developer, one of the key qualities that you should have or focus on building is breaking down, like if you're given a feature or a huge business case to implement, you should be able to break it down into smaller problems and eventually smaller code reviews, right? And
Yeah.
like you said, there's like lesser chance of regression. It's digestible for everybody. It's easier to ship. So I hands-on agree. I don't think I have anything more to add to that actually. That's
Yeah.
like a very good summed up point.
Yeah,
Like,
I
raise
just want
reasonable
to say one thing though, like it's not always possible.
Yeah.
Sometimes you do end up with a little bit of big CRs because
Right.
of legacy debt and like the code is not that modular. But in those cases also you should actually think why that was the case
Exactly.
and try to solve that. Like
Yeah.
I think ultimately that if you are forced to do big CRs, it points to the fact that your systems are not really independent. They are like tightly coupled, and you should be looking to separate that anyways,
Yeah.
right? So that kind of learning also is something that you should look at.
Yeah. Do you want to give an example though? Like, I can think of one example. Like, if you have something that changes, like the contract between the services, then the first iteration can just be the contract change, ensuring that it does not regress anything. And the next one can actually be, making sure that backward compatibility is maintained and actually start populating those things. So, is that what you mean, or do you want to elaborate more?
Yeah, I think if it is two services, obviously CRs will go out separately
Yeah.
only. But I mean at more granular level.
Yeah.
So for example, if I have to give a very crude example, it's very hard to give an example without going deep into a
Yeah.
project. But on a high level, let's say you're creating a new kind of request, and that request has certain statuses, right? It can be pending, in
Yeah.
progress, it can be errored, it can be delegated, whatever. You should first ship out just those statuses as a separate CR.
Yeah.
You should not club it with the implementation of those
Yeah, that's
statuses.
what I meant by contract changes
Yeah,
as well, right?
right,
You
so-
first introduce the norm and then do the implementation.
Kind of, yeah,
Yeah.
right. So same thing goes for if you want to take an easier example, web dev. It's digestible by many people,
Right.
simpler to implement. If you're doing web dev, when you do backend, you don't implement the whole backend at once. See what you can implement in smaller parts, and at the end you come to the API tying part. First
Right.
implement the internal pieces, right? So yeah, that's what I would suggest.
Okay.
Shall we go to the next one?
Yeah, yeah.
You shoot me one.
So I think I've stressed about this in like previous videos as well. But I think one of the key qualities that sets you apart as a good developer is focusing on your documentation skills. Do good documentation of your code, do good documentation of whatever designs you're building. I think it sets you apart. It is one of the highest forms of communication you can build with your extended team, because it is necessary, right? You will make it easier for other people to work with you. You will make your life easier by, you can go back to things and revisit them because everything is documented. So I do think that's like a necessary skill to build. What do you think?
I agree, but what is your definition of documentation? I agree on the overall point, but I want to just get into the details of documentation.
So I would say, like, documenting your code, if you have added a new class, making sure you document functionality within the code. If you have
documented where?
Within code, as comments.
As comments, right?
Yeah.
You mean as comments?
I mean as comments.
Docs.
Yeah.
For example, it's Java doc.
It's Java doc.
What,
right?
is it something similar for C?
I mean, you can add like markdown files in repository as well, right?
Okay.
And I've seen like a lot of good developers also maintain this practice of adding like MD files, as design within the repository. I think that is also a good practice to maintain if you have to document like design along with code. Else, I'm sure like a lot of organizations have like shared repositories of like where you can just put documentation in, right? So I mean documentation from both sides, like documenting your code and also documenting like, how to debug things or what the design overall flow is. So I want to cover both of those things.
Yeah. So I have a couple of opinions on this. So I'm agreeing on the overall point, but I feel like documentation within code is way more important than documentation outside of code. Why? Because from my personal experience, I have seen documentation outside code start off well, but become stale very fast because it's just not connected, and someone has to go and make the effort of updating that, and over time some developers miss it, and that just starts a domino effect that, hey, I cannot do my update because the person before me hasn't done his update already, and it leads to staleness there.
Correct.
So in well-intentioned teams, and like if team can stick to schedule, that is the best. But I feel like that's very hard to enforce over the years, right? So documentation within the code, I place higher priority.
I agree with that.
Right. And for me, documentation within the code doesn't end at comments. I feel like people don't actually put that much effort into thinking what their function name is or what their variable name is. But I feel like that is also something that falls in the realm of documentation, right?
Totally
because
agree.
That's the first thing you read about using something. Like if you're using a function, the first thing you'll read is the name. And if that name can tell you everything, that's it. That's good enough. Right. So you agree on this?
I do agree on this.
But this is a great point. I think documentation is definitely something that I personally look for in like when junior engineers transition to mid-level and senior engineers. I feel like this is something I definitely look at, like how are they developing on this front. So
are they still naming their variables A, B, C and X, Y, Z?
I think ABC is the first stage, but even after that, once they start naming them at least with some correctness, then comes the advanced level, right? So one thing, I can actually give you an example here. Okay, so if you're naming a boolean as to what it does, that's great. But if you're naming a boolean as to what the check is itself, that's better.
That's better.
Right. So an example of this I've seen is, like let's say there's a customer object and you add a boolean function there which checks whether this customer is a premium customer. So a good name of that is premium customer, right? But I've seen people name it as like check premium customer. Right, so that should check premium customer is not a right name. It should be is premium customer. So I know this seems very pedantic, but it makes a difference.
It makes a difference, of
right?
course.
So I totally agree. So documentation, I think I would rate it as one of the highest requirements to be a competent engineer. Right?
Next one.
Let me see which one I want to share next. So I think I already shared one code one. So I want to ship into another domain, and I think I want to say like. As a competent engineer, you should know how to communicate with intent.
Okay, elaborate.
And I'm going to elaborate on it. So communication, I think, is a very undervalued topic. A lot of people don't think about how they communicate. But in a complex field of problem solving, communication is the key thing for team collaboration, right? When you're talking to your senior engineer or your peers or your manager, you need to communicate very, very effectively. And the thing that has worked for me personally is that if I communicate with intent, which means that I communicate with an opinion in mind, I communicate better. Otherwise, I'm just rambling, right? I'm just like rambling, like, I'll try to explain, I'll jump from ship A to ship B, I'll weave like 10 topics together. So that if that intent is missing, I lose out on the conversation, I lose the other person, and the conversation goes nowhere. So I believe communication with intent is key for being a competent engineer. What do you think?
Yeah, I think eventually this comes down to something that we've also mentioned previously, which is like valuing other people's and your own time, right? You value their own time, value your time. My laptop is taking off. It's overheating.
Oh, okay. I was thinking, where is that noise coming from? Like, it was like, I was like, is that a plane?
It's about to take off. Yeah. So as I was saying, that you have to like value your own time, other people's time, their limited focus which they have decided to give you, and you have to make sure that it is your responsibility that if you have reached out or if you have set up the meeting, your points have to be communicated effectively and efficiently so that everybody can make the best of that time, right? So I think that's a great point to add.
I also want to take this into another aspect. So I think a lot of times, as if you're a competent engineer, you will be expected to answer things about prioritization and like whether we should do task A or task B. And actually, if you're not doing that already, you should be dictating that, right? Because that's what engineers are expected of. They can tell you what to prioritize and what to not. You should not just be a machine, which, I got a Jira ticket, I'm going to do this Jira ticket, right? Ultimately, you have to build things. So you have to think what tasks are important and what are not important, right? And I think communication with intent also covers that. So if let's say think of it this way, there are 2 bugs. One bug makes it very hard to use a feature 1. Second bug is an edge case that breaks feature 2. Now you should be able to convince your managers, your peers that the second bug is what we should fix, because customers can live with the pain, but they cannot use a broken feature. And that, I mean, it sounds easy right now, but once you go to convince, people will have 100 opinions and you have to drive it around and come back to the conclusion, right? So I think that is pretty important, and that's where again communicating with intent is really useful. I can drop a couple of books in the description if people are into that, and they can read it to get better at it. Right.
That makes sense.
Shoot me the next one.
Okay, so my next one, I've tried to phrase it like, in a TLDR kind of way, which is like design first, code last. Which means that, coding is kind of like the last stage where you go to like a business use case or, to implement something. But I've seen a lot of developers jump into code first and, they'll be like, I'll just figure out cases or edge cases as and when I go. I don't think that's the right way to approach a problem, right? In my opinion, if something requires like changes across multiple modules or if it's solving multiple use cases, you really have to sit down, document your workflow, discuss it with other engineers like, hey, this is what I'm planning to do, this is what I'm going to implement. And only once you've ironed out all the nitty-gritties of the things, only then you go ahead and try to code and implement it. What do you think about this?
I generally agree with the principle. I want to break it down more again here, right? But I think for edge cases and everything, definitely you should be making sure that you know everything first before coding, because I have seen so many times where people go and hit a roadblock later, which could have been easily caught if they spent time thinking about it. Personally, I have done it too, right? I do agree that there's a trade-off sometimes. So do you think, first of all, do you believe in a POC-based approach for some projects?
For some projects, yes. Like in some cases where like maybe you have not explored this area before, or if you're exploring a new tech, new business use case that hasn't been done before, then obviously doing a POC makes sense, and then you can iteratively design on it to and figure out how to make things better from there.
But I think POC also can fall into this, right? Because even for making the POC, you should first decide what the POC is, design it, and then execute the POC. You should not just jump into the POC itself. And I think that's one thing I distinctly remember one project where I jumped directly into the POC, and I realized that even though I did the POC, I never knew the kind of answers I wanted. So I think it's very important to design and decide ki, okay, I'm doing a POC. I need these questions answered
Exactly.
succinctly.
Yeah.
Right?
And then you also kind of weigh in on the things that, okay, for the POC, I can hard code this, I cannot hard code that. This is something that still has to be dynamic. So all that stuff has to be like, that's all the design part of things, right? Like in the end, you're solving problems, and code is basically the final leg of it, where you actually go and implement it. But the real problem is the thinking part. And I think a lot of developers kind of get confused with that, where they're like, hey, I'm just going to code this and get it done with. But that's not the right way.
Yeah, correct. I agree. So yeah, that's a good point. Do you have anything else to add?
No, I think I'm good.
Okay.
Shoot
Do
me
I
the
have to
next
shoot
one?
one?
Yeah.
So, okay. So my next one is, and probably my last one, right, is that the difference between a good and a great engineer, I have often noticed, is how they write code and how easy it is to test. Right. So I feel like a lot of people can write good code, right? Like after a point, you will be able to ship out code that at least works. But the difference between really good code and good code is that really good code is so easy to test, right? And I think that comes to your point also, that when you design first, you also decide how you are looking to test this piece of functionality, right? So first, I want to give details example, but I just want to hear your original opinion on this.
So I think I agree that like writing good code also means that you're writing like good testable code, and you're not just like, hey, you're just doing like if else hello world testing and just shipping it out. It has to be testable.
Yeah, I think if else will kind of make it sound like that add a lot of tests.
Yeah.
But that's not exactly what I mean here. What I actually mean is that the code itself should be testable. So for example, I have this order in my mind that whenever I'm writing something, there are 3 levels of testing I can do. First is my local level testing. I can test in my machine. Second is somewhere between full test and local tests. You can call it hybrid test. And the final one is integration test, where I actually have to deploy to a mirror environment, which simulates everything in production, and I have to actually test the code there, which will take a lot of time. Usually, right? Because those environments are not usually available for every developer. It will be a shared resource, and you have to book your time on it and go there and do it. So I always try to see that, like, if I'm developing, I need to be able to write code that I can test in my local machine itself. That's the best case scenario, right? So you have to think of ways to design your classes, your whole architecture, that you can test it in your local machine, like by simulating it. So do you agree the difference here now?
I do. So you want like, it has to be like, I think the term we're looking for is like, you should always be able to at least write unit tests for your code.
More than unit tests, right? So it's not unit tests you can write, of course, but it should be able to give you confidence that it will work in the real life system because your testing is so good. Let me give you a very good example. So in my line of work, we deal in real time systems. So what I mean by that is that the clock plays a really important part. Whether if there's a job, is it the right time to execute that job or not, right? So it's a real time system. It continuously executes. Right. So now the clock object plays a really significant part. So what we try to do is, instead of using the clock as it is, we try to separate that clock from the overall implementation, right? So what happens is, while testing, I can inject a clock that I can control. Right. It's so let's say I want to test something that does not execute for 6 hours. Now, if I have to do in a real-time environment, I have to open that job in my mirror environment, wait for 6 hours, and then go. But since I can inject the clock in test, I can just simulate 6-hour passing in my local environment, right? So that's the kind of testing I'm looking for here. Right. So yeah, that's I think I added a lot on this. So I'm going to give you again a chance, like if you want to add anything else.
That's a good point. I see what you mean now, and I agree.
All right. Yeah, that's my tip. Do you want to shoot the next one?
And I think this is also going to be my last one. The next one I wanted to bring in was like being able to choose between when to go for code redundancy and when to like generalize your code. What I mean by that is that if you're working on something, right? And you see that a module is kind of there, but it is not generalized enough. Instead of like writing a new class or going back and implementing a new thing, you should kind of focus on how you can make that second use case work with the existing one by abstracting things out and making sure it works for both the business problems, right? So that way you end up avoiding code redundancy, and you also like end up doing some code abstractions that can be reused later.
Yeah.
What do you think about this idea?
I generally agree. I think abstractions wherever needed
Yeah.
are really good. I think abstractions are very tough to get right,
Yeah.
and a lot of times, like sometimes they end up being a hindrance for
Yeah.
future development. But I like the idea that you suggested that the second person should be doing the abstraction, not the
Exactly,
first person,
right.
so that at least he can, see both real world use cases and try to combine it into one
Right.
solution.
Yeah.
But tell me this, do you think, what do you judge an abstraction on? So let's say, for example, let me try to think of an example to what I'm trying to say.
Yeah.
Let's say there is a, okay, what can I use an example which works here? Yeah, okay, so let's say I have an iPad and a book, right? A hard-coded book. Now
Yeah.
I have to represent both of these as classes,
Right.
right? Because both of them can read books. This is a book itself, and
Yeah.
an iPad can load a book.
Yeah.
Do you think I should create common classes for the covers of these?
The book covers?
Yeah.
Yeah, I think so, right?
So because they're both photos, right?
Yeah.
Here it will be printed.
Here it will be loaded. Right? Yeah.
So in this case, that's what I want to ask. Like in this case, you judge that this is the right abstraction.
Right.
What are the reasoning behind it?
The reasoning behind it is like you have to kind of like look at it as the functionality is eventually the same, right? The end purpose is that here you load a book, the person reads it. Here as well, you open a book, the person reads
Yeah,
it,
so-
right? The end business use case is kind of same, right? But it's only the implementation part that's different.
So
Right, so you
ultimately,
can-
it saves money.
It saves money.
Because you
Yeah.
just have to save that cover once.
Yeah.
And it can be printed onto a book, and it can be loaded
onto an iPad, right?
Yeah. Okay.
Yeah.
So I think you have to basically look for those kind of factors.
Yeah.
Like
Where it
should
all ties up to the same.
yeah, to business goals,
Right.
right? Like, but is it always business? I think optimization is also a business goal only in the end, right? So
yeah. And I think we were discussing this before, like sometimes you can have like entirely two business use cases, but the technical implementation
Yeah.
can be the same. But I think that's the thing. Overall, if you like develop your skills in the same way, you will develop an eye to identify that. And I think as a developer, that's pretty necessary, that you have to look for opportunities where you don't necessarily have to reinvent the wheel. You just have to
Yeah.
make the wheel better,
Yeah.
right? So
And I think that is applicable to a lot of real world scenarios. Like, if you, for example, take Redis, right? So Redis is a great example of how the same tech can be applied to so many different problems, right? So I think I have seen Redis being used in fast intraday trading. I have seen Redis being used in gaming dashboards. Like you have this gaming leaderboards, right? Global leaderboards. It is used there. So it's always possible that two wildly different things are the same thing technically.
Yeah.
So keeping an eye out for them and abstracting them is your best bet at
Yeah.
being a good engineer. And I think that's one of the core qualities.
Right.
Yeah, nice. So I think abstraction, we should do another episode. I think we have a lot to discuss
Yeah,
there.
I think it'll be good to do like a deeper dive of like just, taking technical examples and diving into them. Right?
I agree, yeah.
Yeah. Okay. So, do you have any more tips before we call off?
No, I think this is good enough for the episode. Just to digest it, maybe we do another one as usual to come back to it.
Yeah, fine. I'm gonna sign off and then we can go back to our off-camera siblings.
Yeah,
right?
I really need to settle that. I need to make sure that, I win in that fight.
Okay. All right. Thanks for watching. Let us know if you have more tips that can, help you be a better software engineer. We'll see you in the next episode. Thank you. Bye-bye.